Hello everyone, welcome to Chapter 1A Pre-Test Review. The idea of recording the videos beforehand, everyone can watch it so that we can have all Monday class time for asking questions. And I can make myself available to all the students who have questions, and then I can answer most of the questions. This way you do not have to take down the notes. You can access this information anytime, anywhere you want. So let's get right into the questions. Question number 1. Order the following from least to greatest. You're given 5 numbers. So you have square root of 25. You can simplify it to 5. The next number is a negative 2.6, followed by negative 1.5, which in decimal format is negative 1.5. Next one, we have pi, the most famous irrational numbers, which is close to 3.1416. And the last one, we have 3.71 without endings, which is 3.7171, and so on. So how do I put them from least to greatest? The easiest way, since I already mentioned it to you, and I already pointed out, convert these numbers into decimals. Most of us are familiar with the decimal numbers rather than irrational numbers, fractions, or without endings. This way you can look on the number line, which number is to the right hand side, furthest to the right hand side, which number is the smallest to the left hand side. You're going to order them from least to greatest, so it means that which number would you put on the furthest left hand side? We will start with negative 2.6, then negative 1.5, followed by pi 3.14, then we have 3.7171, and the last one is 5. I would like to point out at this point, I am not drawing them to scales. Those numbers are not drawn to scales. So basically, I'm just telling you the location. The furthest one would be negative 2.6, and to the furthest left, and 5 is to the furthest right. So how do I write my answers? I'm going to write it back what I'm given. Okay. So we have negative 2.6, followed by negative 1.5, then pi 3.71 without ending, and the last digit will be square root of 25. This way, I can put them in order. Question number 2. Complete the table. You are given words, number line, inequality, interval notations. One of the information is given to you, and you're asked to fill out the other 3 pieces of information. So take a look at the first one, numbers greater than 2. How do I mark it? So since 2 is not included, it says greater than. So I put an open circle. Be sure not to fill your endpoints to circles. Keep it open, unshaded. And any numbers to the right would be our solutions. For the inequality, I chose the variable x. So x greater than 2. How about the interval notations? The endpoints 2 is not part of our solution, so we would have to use the curvy bracket, which looks like an open parenthesis. 2, comma, infinity. Next one, you're given the interval notations or. So I have negative infinity up to negative 1 or 2 up to infinity. So the words would be represented as numbers less than or equal to negative 1. So again, look for the information. It's a square bracket, so it would contains the equals to. The other information from 2, I would read it as or numbers greater than 2. So how do I mark it on the number line? from negative infinity, so that's our left end, up to -1. So this time -1 is included. It's equal to, so any number from negative infinity up to -1, followed by 2. So there's no equal sign. Keep it open circle up to infinity. How do I fill the inequalities? So any number less than -1, so it's being represented for this one. Any number greater than 2 is being represented with this one. Question number 3. Show and/or explain the method shown in class for estimating square root of 56 to the nearest 10th. As we explained in class, 56, what's the next perfect square that's closest to 56? So on the lower end, we have 49. On the upper end, we have 64. As we take the square root of 49, it turns out to be 7. As we take the square root of 64, it turns out to be 8. So we narrow the numbers to the first digit. Next, how do we estimate to the nearest 10? So we need the decimal after the first digit after the first decimal point. Is it going to be closer to 8 or 7? You can see the difference between 64 and 56 is 8. The difference between 49 to 56 is 7. So we know it's going to be closer to 8 rather than 7. So the numbers we're testing is going to be 7.4 squared, 7.5 squared. After we calculate it, it turns out to be 7.4 squared is 54.76. 7.5 squared is 56.25. So we know it's going to narrow down to square root of 56 falls in between square root of 7.4 and 7.5. And the answer is going to be square root of 56 equals 7.5. Question number 4. Simplify. So this time, remember, don't use your calculator. Do not use your calculator to give me the decimal numbers. When we simplify radical expressions, all we need is to factor out the greatest square root. Square number is inside your square root symbol. That's all. Leave it. Irrational number is still a number. So don't bother using your calculators. So now let's take a look at 4a. Negative square root of 32. So what are the factors you can factor the 32 into? And that contains the greatest, the biggest number of perfect square. Can I make it into square root of 16 times square root of 2? So what's square root of 16? So square root of 16 is a perfect square number. So I have negative 4 times square root of 2. 4b, 5 square root of 3 minus 9 square root of 12. So at first look, they don't look the same. So your first job is to make them into the same radical expressions before you can do anything else. So for 5 square root of 3, there's nothing else I can do because 3 is already a prime number and there are no perfect square inside the radical expressions. But the 12, I can make it into 4 times 3. And I know square root of 4 is positive 2. So square root of 4 is positive 2. So as I take it out, I'm only left with 2. So again, this is 9 times 2. So I'm trying to emphasize here, we are doing the multiplications so far. 5 square root of 3 minus, so 9 times 2, I have 18. Now we have the same radical expressions, root 3, root 3. So we can add and subtract. In this case, this is a subtraction. 5 minus 18, which is negative 13 root 3. Letter C. You have a radical expression at the denominator, which we do not like. So how do I simplify it? And as you can see, 21 is inside the radical expressions. 7 is inside the radical expressions. So I'm just going to go ahead and divide the two numbers, then take the square root of it. And it happens that 7 does go into 21 3 times. So I'm reducing 21 with 7, and I do not have any radical expression at the denominators. So I accomplished my goal. to get rid of the radical expression at the denominator is the simplification process. Letter D. Square root of 18 times 2. So again, two numbers are inside the square root. So can I multiply them together first? Then take the square root. Yes, you can. So what's 18 times 2? 18 times 2, that's 36. Is 36 a perfect square? So by now you must have enough practice. Square a number, it happens to be 6. So 6 squared is 36. Letter E. 12 divided by square root of 6. So again, I do not like the denominator to have a radical expressions. So what do I do to rationalize it? I'm going to multiply top and bottom with the denominator. So square root of 6 multiplied to top and bottom. Using the concept of what is square root of 6 times square root of 6, making that into perfect square, which just happened to be 6. So take out the radical expressions at the denominator by multiplying what I'm given for the denominators. Now 12 divided by 6. These numbers are outside of the radical expressions, so I can definitely simplify it, which turns out to be 2 root 6. That's my final answers. Letter F. Square root of 24 plus square root of 6. Square root of 24, are there any perfect squares? So 4 times 6, that's 26. So is 4 a perfect square? Yes, so I can take it out. Make it into 2 times square root of 6 plus square root of 6. So our final answer, since square root of 6 and square root of 6 are the same, so I'm adding the coefficient. 2 plus 1 equals 3. So that's 3 times square root of 6. Letter G. 4 times root 3 divided by 7. How do I rationalize it? So this is very similar to letter E questions. I do not like the denominator to be an irrational number. So what do I do? Without thinking further, I just go ahead and multiply the exact same given denominators, root 7 top and bottom. Root 7 times root 7, so that's root 49. Turns that into a perfect square. So the whole idea is to make your denominator a perfect square in order for it to be able to get rid of the radical expressions. Square root of 49 turns out to be 7. So there's no more radical expression at the radical expression of my denominator, so we achieve our goal. Letter H. Do I really have to multiply my denominator with square root of 16? It's kind of big. So if you can identify square root of 16 is actually a perfect square, 16 is a perfect square, I can just go ahead and take it out, making it not an radical expression anymore. So I have 7, square root of 7 over 4. Letter I. Square root of 5 times square root of 20. So I'm going to try to multiply these two numbers together first. So what's 5 times 20? It's 100. 100, is it a perfect square number? Again, if you practice enough, you'll find square root of 100. 100 is definitely a perfect square. So the end result is going to be 10. Question number 5. Evaluate each expression for the given value of the variables. Number 5, you have the A value equals to 2, B equals to negative 3. So go ahead and plug that into the equations given. So A is going to be replaced by 2. So I have 2 squared divided by 3. B is going to be replaced by negative 3. When it is a negative number, remember I asked you guys to put a parenthesis so you do not mess up the sign. So what do we have here? 2 squared equals 4. Divided by 3, that's the first term. How about the second term? So we have negative 6, 2 times the negative 3, that's negative 6 divided by 4, which you can reduce it down to negative 3 over 2. Or we can just go ahead and make the same denominators. Make them into the same denominators. So the least common denominator between 3 and 4 would be 12. So in order for 3 to become 12, I have to multiply it by 4. In order for 4 to become 12, I have to multiply it by 3. If you're not familiar with this process, make sure you review your fractions. So 4 times 4, I have 16. Negative 6 times 3, I have negative 18. 16 minus 18, that's negative 2, divided by 12. So our final answer is going to be negative 1 over 6. Number 6, d squared over 2cd. Now plug it in, c equals to negative 2 and d equals to 3. So d, whenever I see the d, I replace it as 3. Whenever I see the c, I replace it with negative 2. So whenever I have a negative number, I put a parenthesis. So 2 times negative 2 times 3. So is there any common factors I can reduce it down to? So 2 times negative 2, that's negative 4. Negative 4 times 3, that's negative 12. 9 and 12 has the same common factor of 3. So reduce top and bottom with 3. I have negative 3 over 4. We like to leave the negative sign on the numerator, at the numerator. So I would strongly suggest you put your negative at the numerator at the top. Next one, simplify each expressions. Number 7. So what does it mean by simplify? You collect like terms. If you have the same variables raised to the same power, then that's called like terms. Same variables raised to the same power. So what's 3x squared minus x squared? So if you are not familiar with this, be sure to review. Okay, I'm going to put them together. Next, what else are same variables raised to the same power? I have 6x and 5x. So I like to put them together. I'm using the commutative rules. And last one, 3. Negative 3y. So there's no other y terms. So that would be my last one. Now I can collect like terms. 3 minus 1, so that's 2x squared. 6x plus 5x, that's 11x minus 3y. And that's it. Nothing else you can simplify or collect like terms. Then leave it is. Number 8. So first thing, make sure you distribute the 2 to both terms inside the parentheses. So you're multiplying 2 to x, multiplying 2 to negative 4y. Now we don't have any more parentheses. So can you collect like terms? So again, like terms are same variables raised to same powers. So I'm using the commutative rule again. 2x minus 9x. 8y plus y. Negative 8y plus y. Don't drop your sign. So what's going to be our final answer? It's going to be negative 7x minus 7y. Simplify each expression, leaving no negative exponent. Assume all variables are non-zeros. Number 9. So the keywords here is leaving no negative exponents. We do not like negative exponents, so make sure you try to get rid of it. So number 9, I have x raised to the 10th power, y raised to the negative 3 power inside the parentheses. It is the same question, exact same questions without the parentheses. Why do I say that? Because when you don't see the exponent outside, that means raised to the first power. So I can directly take it out. So which one does have the negative exponent? So that's the variable y. So how do I deal with the negative exponent? All I have to do is, since it's at the numerator, then I put it to denominator. So again, flipping it from top to bottom to get rid of the negative sign. Number 10. So now you have a negative 4x cubed times y to the negative 2 power divided by x squared, y to the 8th power. So for number negative 4, there's nothing else, so I'll just leave it up there. For x cubed divided by x squared, so obviously 3 is greater than 2, so I'm going to leave the bigger number and subtract the smaller number. How about y raised to the 8th power, y raised to the negative 2 power? So this time I am putting, again, 8 is bigger than -2. So I'm subtracting. So don't forget you are subtracting a negative number. Put a parenthesis so you do not mess up the signs. So -4 times 3 minus 2, I have x raised to the first power. When your exponent is 1, you do not really have to write it. At the bottom, we have y minus -2. So what's y minus -2? Minus -2 becomes positive. So y raised to the 10th power at the denominators. Number 11. You have 5 outside of the parentheses. So we discussed this before. Does this 5 get raised to the -2 power? It's not inside the parentheses. So do not raise that number to -2 powers. How about a cubed? B inside the parentheses raised to the -2 power. So first thing, instead of doing anything else, I'm going to just directly put it to denominators. So I have 1 over a cubed b. Now since I put it at denominator, I can get rid of the negative sign. Then I raise it to second power. So a raised to third power followed by another second power. You multiply the exponent. 3 times 2. B raised to the first power followed by another second power. So 1 times 2. B raised to the second power. So that's it. Or you can write it in a more concise way. 5 over a raised to the 6th power. B raised to the second power at the denominators. Number 12. So something inside the parentheses. So first thing I would like to simplify. Is there anything I can simplify? So obviously m raised to the 5th power, m raised to the -1 power. So I'm flipping the m raised to the 1 power to the top, which makes it into 5 minus -1. After I simplify it, then I deal with the numbers outside. So 5 minus 1 turns into 6. -3, n to the second power. Now I'm ready to raise it to second power. So remember, any number, all numbers inside the parentheses get raised to second power. So m raised to the 6th power followed by another second power. So m raised to the 6 times 2, which is 12. -3. So this is the number I would like to emphasize. -3 get raised to second power at 2. It's at the bottom, so keep it at bottom. So what's -3 raised to the second power? That would be 9. N raised to the second power, then followed by another second power. So that's 2 times 2, which is n raised to the 4th power. Last section. Simplify each expressions. Write answers in scientific notations. So please review the information about scientific notations that we discussed in class. Number 13. 2.5 times 3. So these are just numbers. I'm going to multiply them. 10 raised to the -4 power. 10 raised to the 9th power. They are the same base, so I multiply by adding the exponent -4 plus 9. Turns out to be 7.5 times 10 to the -4 plus 9, which is 5. Is this in scientific notation already? So scientific notation says the first digit would have to be non-zero, and all the numbers, rest of the numbers would have to be in decimal. So it definitely designates as the first number. The rest of the numbers are being represented using the 10 to the 5th power. Number 14. So again, I'm going to do the number division first. 10 to the 8th power, 10 to the -4 power. They are the same base, so I can deal with that. So what's 7.2 divided by 1.2? That is 6 times 10 to the 8 minus -4. 8 minus -4. Don't forget, you are subtracting. Dividing means that you have to subtract the exponent. So the final answer for number 14 is going to be 10 times 8 raised to the 12th power. Is it in scientific notation? So again, we have The first digit as non-zero, and the rest of the numbers are represented with 10 to 12 power. So this wraps up our Chapter 1 review. Please be sure to practice your perfect square numbers, your exponent. Review all the properties that we discussed for the exponent. And one last thing, study the number line conversions, multiple representation for your number line, word descriptions, inequalities, interval notations. Review this packet early, get yourself comfortable. The chapter test itself is going to look exactly the same pattern. Identical questions, except I'm going to change the numbers. If you are ready for the review, you will be ready for the chapter test.